the weather conditions for our sort of conference day. The first sort of part of the first section of the conference, Building Materials, Media of Modernity, is taking in its sight again the old diva. We talked yesterday a lot about the Bauhaus building as it described as a, so to speak, not only icon but even in its behavior like a diva. So let me introduce very briefly the conference panel, and then we continue with the talks. Leonardo Benevolo's history of architecture in the 19th and 20th centuries is considered one of the early comprehensive historiographies of modern architecture. Published in 1960, volume 2 contains photographs of the Bauhaus building, juxtaposed with historical photographs from 1926 and photographs of the building from around 1960, some of which still show the brick infill of the facade on the courtyard side. Benevolo asserts that the distinctive feature of modern architecture exemplified by the Bauhaus building is that it expresses and organizes the aspirations of the society. And I quote him now. Now that the former life has disappeared and the work is nothing more than a pitiful pile of rubble, strictly speaking, the Bauhaus no longer exists. It is not a ruin like the remains of ancient buildings, and its site no longer enchants. It resembles an empty cocoon from which the butterfly has emerged, quote end. The morning panel, Building Materials, Media of Modernity, examines the role of new materials shaping the narrative of modern architecture. Benevolo also highlighted the connection between industrially manufactured materials such as glass, steel, and concrete, and a radically new architecture that is, above all, an expression and articulation of a new society. However, if buildings lose this connection between context and content, they sink into insignificance. In this narrative, buildings such as the Bauhaus are a medium through which ideas of modern society were produced, organized, and verified. This conference section questions these cultural meanings and constructions of modernity associated with modern materials such as glass, concrete, and steel. In her first contribution, Kathleen James Chakraborty, most welcome, places modern buildings celebrated for their materiality in the context of the transatlantic exchange within the construction industry, and thereby drawing attention to the blind spots in architectural historical narratives. Kathleen James Chakraborty is Professor of Art History at University College in Dublin, where she leads the European Research Council Advanced Grant Project, Expanding Agency, Women, Race, and Global Dissemination of Modern Architecture. She is co-author of the Belgian Friendship Building, From the New York World's Fair to a Virginia HBCU, published in 2025 by the University of Virginia Press. But Kathleen James Chakraborty is very known for her publications and contributions to the field of Bauhaus studies, and so far we couldn't have wished to have a better speaker for this panel. So again, looking very much forward to your contribution. Just for you, an orientation for the program. The presentations will follow one another, and afterwards we will have enough time for Q&As. So the floor is yours, Kathleen. Thank you for coming.
It is always a treat to be in this building and a special honor to be speaking from this stage. So I'm very grateful to Regina and all of the organizers. Visiting this building in 1985 was what made me a historian of German modernism. And so it's just always astonishing to be back. Now, in my current research project, which Regina just named, I'm expanding agency, women, race, and the dissemination of modern architecture. I'm demonstrating the degree to which middle-class and wealthy women in the United States became well aware of modern architecture through a magazine called House Beautiful, even when they chose not to embrace it. This morning, I want to make a parallel point about another body of literature. By overlooking the German engineering treatises of the day, much of which remain admittedly almost incomprehensible to art historians like myself, we've overlooked the series of transatlantic exchanges that provided the foundation for the ones we've long credited with informing the design of this building. We've valorized the image of the new over what the engineers prized as the most innovative reinforced concrete buildings of the day. Historians of architecture have long acknowledged the importance of Walter Gropius's publication in 1913 in the Werkbund Jahrbuch of a sheaf of photographs of reinforced concrete grain silos and daylight factories built in the early years of the 20th century in Argentina, Canada, and the United States. Their impact upon Gropius's work, including the design of this building, as well as upon such contemporaries as Le Corbusier and Erich Mendelsohn, is also widely known. Less often recognized, however, is that several of these structures, and many that were similar to them, already featured in a separate body of literature, of which the three architects, Le Corbusier, Gropius, and Mendelsohn, probably had only a superficial awareness, but which were certainly familiar to the leading German construction firms of the day, not least because their engineers had authored parts of them. Emil Morsch's, the most notable of these were Emil Morsch's Der Eisenbetonbau, seine Theorie und Anwendung, published in 4 editions between 1902 and 1912, Handbook for Eisenbetonbau, edited by Friedrich Ignaz von Amperger, which was originally published between 1907 and 1909, but went through many subsequent editions and was in many volumes, and a supplementary volume to von Amperger's handbook, Die künstlerische Gestaltung der Eisenbetonbau by Emil von Messeneffi, which appeared in 1911. Although both examples of the enormous print culture architecture was generating by the early 20th century in Western Europe as well as the United States, the Werkbund Jahrbuch and the Handbook for Eisenbetonbau were very different kinds of publications. The Jahrbuch was relatively compact, printed on high-quality paper with a format that leaves plenty of space around the text. It is an example of the high standards of graphic design espoused by the organization for which it served as the house organ. Moreover, although only 2 other illustrations were inserted amid the relatively brief essays, 108 pages of plates of German industrial and commercial architecture followed. A further set of plates illustrated well-designed advertisements, many of which were republished in color. So this felt like a fancy object. All of this illustrative material was equally generously laid out, with seldom more than 2 images to the page, and printed to a very high standard. The audience for the publication presumably included the constellation of industrialists, critics, designers, and architects that comprised the membership of the Werkbund, as well as well-educated, informed, upper-middle-class public that were the targets of its efforts. Little specialized knowledge of architecture or design, as opposed to a more general debates about contemporary German culture, was necessary to appreciate the Jahrbuch. Moreover, much of its impact could be gleaned from a survey of its ample illustrations, rather than from reading the text. This was exactly the kind of publication, associated as it was with advanced design, that was eagerly read by ambitious young architects such as Mendelsohn and Le Corbusier, who in the 19-teens both began to assemble what we would now call a data bank of images upon which they could draw in the invention of new architectural forms. For them, as for Gropius, these were illustrations rather than real buildings. They had little idea where they were, who had designed them, how they were constructed, or how they were used. The handbook was a very different affair. The mixture, wait a minute, my slides are off, I'm sorry. I thought I had one there. No, it's just that what I was seeing here and what was there were maybe not the same. Anyway, here we are. That's the right slide. That's the handbook. Apologies for any earlier confusion. The handbook was a very different affair. The mixture of typefaces on the title page of the opening volume announces that the press, although a prestigious one, was not au courant with the latest graphic design. Yeah. Although the text is printed using Roman lettering rather than Fraktur, the neo-medieval typeface that was still common in German publishing, including for newspapers and used in the introductory essay of the Jahrbuch. The text is illustrated, but with small photographs that seldom shown at the ample scale of those included in the Jahrbuch. Moreover, because they are placed within dense pages of text, the aesthetic qualities of the buildings shown hardly leap out at the reader. Indeed, many are details of structures which are being shown to illustrate either best practice or particular flaws. The photographs are supplemented with a plethora of technical drawings, structural diagrams, and graphs. The text in many places consists largely of formula and tables. This is not a book likely to engage a layperson or even an architect or architectural historian. I admit I've read pages of it, but only pages. I mean, 13 volumes plus another volume here and another volume there. No, this is a formula that, trained as an art historian, I don't really understand. I'm not sure that Mendelssohn and Le Corbusier read any more of it either. I'm not sure they even, I'm sure that Mendelssohn was assigned to read it as a student. I don't know that he opened it. Indeed, bridges, water towers, lighting poles, tunnels for everything from mines to subways and other infrastructure receive at least as much attention here as buildings. Many of the photographs document their construction rather than illustrate pristine, completed compositions. The range of examples is extensive, and American examples, including of such mundane structures as a water filtration system in New Haven, Connecticut, and a triplet of neighborhood-scaled railway overpasses in Richmond, Virginia, abound. German engineers were well aware, let me see, yes, that's what I want, of the latest developments in the Americas. For instance, 2 grain silos, one each from Argentina and Canada, that became iconic due to their republication following the Werkbund Jahrbuch in Le Corbusier's Vers in Architecture, can be found already in these publications. And I show you the pages from Vers in Architecture, and many of you will know that the photograph at bottom right from there of the grain silo Le Corbusier has cut out the parapet of that building, which doesn't suit his aesthetic purposes, but which was still shown in Gropius's Jahrbuch essay. The Buenos Aires example, many of these can be found already in these earlier engineering publications. The Buenos Aires example appeared in von Messensefi, while the Grand Trunk Pacific Elevator in Fort William, Ontario, in Canada, was published in extensive detail in the 4th volume of the 1913 edition of the handbook. And I haven't, this time around, found an earlier edition to check, preparing for this talk, but I think it was there already. The pages of these treatises are packed with examples from the United States. These include the smokestack of the United Shoe Machinery Factory in Beverly, Massachusetts, built in 1903 for the company with which the patron of Gropius and Adolf Meyer's Fagus shoe last factory was cooperating. So we know that both Gropius's patron and Gropius knew this building. It was published in 1915 in the 2nd edition of the handbook, but I haven't yet been able to get a copy of the 1st edition to see if it was there as well. And these volumes and editions just go off in all directions, and different engineering libraries can have several of them. For Gropius and readers like Mendelssohn and Le Corbusier, these buildings represented an American primitivism, a contemporary equivalent to the archaic monumentality of ancient Egypt that Gropius and Meyer quoted in their facade for the Werkbund exhibition held in Cologne in 1914. What the engineering literature reveals is not simply that German construction companies like Weiss and Freytag and Dijkhoff-Widman were already well aware of this architecture and how it was constructed. It also demonstrates two other important factors that are as easily overlooked by architects and architectural historians as the very existence of these volumes, which were clearly very influential at the time, not only because they go through multiple editions, but because they can be found still in engineering libraries around the world. The first is that the very engineering that the avant-garde admired as an exotic source for a new approach to architecture had in fact been conceived in concert with German engineering expertise. The second is perhaps less surprisingly that what the engineers most valued about reinforced concrete, in addition to its resistance to fire, the thing they admired most, was its plasticity, a quality that neither Gropius nor Le Corbusier much exploited in the interwar years, and that even Mendelssohn largely shied away from following the drama of constructing the Einstein Tower. It was here, in buildings quite different from the contrapuntal geometries of constructivism and de Stijl, or what was for these engineers the relatively banal grid of Albert Kahn's automobile factories, that they located concrete's most innovative aesthetic potential. Ludwig Mies van der Rohe's concrete office building project of 1923, the Dessau Bauhaus in which we are now sitting of 1926, and Erich Mendelssohn's Schocken department stores in Stuttgart and Chemnitz, opened respectively in 1926 and 1930, all show the clear impact of the American daylight factories that Gropius had published back in 1913. And I show you the Ford factory at upper left, one of those. What is perhaps more important, however, than demonstrating that German engineers were aware of developments on the other side of the Atlantic is that those very developments across the Americas were often indebted, as I've said already, to German expertise. Many of the factories Gropius and others admired were the work, for instance, of engineer-architect Albert Kahn. Kahn himself had been born in Germany and continued throughout his career in Detroit to have access to the most recent German literature on concrete. He designed the main library of the University of Michigan, the institution that has recently digitized some editions, some volumes of the handbook. In any case, Morsch's work appeared in an English translation already in 1909. In 1906, Morsch published the Daimler automobile factory outside Stuttgart that dominates the slide. Clearly, issues of aesthetics and representation had not yet trumped a more old-fashioned fusion of pragmatic signage and function, as they would soon do in the AEG turbine factory in Berlin. But from an engineering standpoint, there's little to differentiate this German car factory from the one that Kahn would soon erect for Ford. But the German factory never appears in Gropius and Mendelssohn and Le Corbusier's championing of contemporary engineering. Although at the time, and nor was Kahn unique in this way, although at the time the most celebrated architects in the United States on the two coasts had largely trained in the approach associated with the École des Beaux-Arts, and when they strayed from that example tended to look towards the arts and crafts movement in Britain. In the Midwest, German influence predominated. Dankmar Adler, Louis Sullivan's erstwhile partner, was another German Jewish engineer who remained fluent in his native language, while from its establishment in 1873, the University of Illinois modeled its architectural education upon that offered in Berlin rather than Paris. Not coincidentally, Nathan Clifford Ricker, who from 1873 to 1910 led the architecture program, was also from 1878 to 1905 the Dean of Engineering. Remember, too, that German remained the international lingua franca of engineering, even if French predominated in more artistically minded architectural circles from Canada to Chile. Morsch, van Amperger, and this is van Amperger, and van Messenetsefi were renowned figures in German-speaking engineering and architectural education, technical experts of the first order. They were well informed about contemporary developments in American construction, not least because van Amperger himself had helped introduce the latest European technology there. The apparent primitiveness of American grain silos and daylight factories did not emerge in isolation from European engineering, but indeed with considerable assistance from it. For Rayner Banham, American concrete structures were important to Mendelssohn and Gropius because detached from their original setting and circumstances, although both of those men would later travel to the United States to see them for themselves, they were examples, paradigmatic examples of a specifically American engineering pragmatism and prowess. Von Emperger was well aware, however, that reinforced concrete was above all a European material, not least because he had played a key role in its adoption in the United States. He arrived there in 1890 and stayed for 6 years. Unlike his Austrian contemporary Adolf Loos, this was not an invisible apprenticeship. He originally worked for the Jackson Architectural Ironworks in New York before establishing his own companies. He was responsible for several of the country's earliest concrete bridges. Even after he returned to Germany, he continued to make important contributions to American construction technology. The Emperger column, for instance, was widely used in the United States. He was only 28 when he arrived in New York. Nonetheless, he was hired by one of the city's leading providers of architectural iron in order to provide them with up-to-the-minute information about reinforced concrete. Peter Jackson, the first cousin of Van Emperger's employer, William H. Jackson, moved in 1876 to San Francisco, where he built concrete sidewalks and manufactured reinforced concrete slabs. During Van Emperger's time at the firm, William Henry Harvey Birkmeyer was the staff architect. Just before Van Emperger's arrival, he and the firm had participated in the construction of the tallest of the buildings you see here, the Tower Building at 50 Broadway, which some construction historians have argued was the first time that a curtain wall was hung on a metal frame. People in Chicago might have different opinions about that. In 1894, shortly after he left the Jackson firm, Van Emperger delivered a paper on reinforced concrete at the annual meeting of the American Society of Civil Engineers, which was later published. In it, he described bridge technology developed by Joseph Mellon, then a professor in Brno, which had not yet been applied in Europe. Commissions quickly followed. All were named for Mellon, for whom Van Emperger served as the American agent. The first of these, completed in 1894, was located near Rock Rapids in Lyon County, Iowa. It's been re-erected on a neighboring site because it's such an important, although small, building in the history of American engineering. Although Ernest Ransome had erected the first reinforced concrete bridge in the United States 5 years earlier in San Francisco's Golden Gate Park, this was the first erected according to the Van Mellon system. The cement was imported from Germany. Also directly supervised by Van Emperger was the Milan Arch Bridge in Cincinnati's Eden Park, which you see in the color postcard, which was the first steel-reinforced poured concrete bridge in Ohio, and the bridge that you see in the black and white in Stockbridge, Massachusetts, which was as radical in its unornamented simplicity as any of the silos and factories illustrated by Gropius. The Milan system remained popular in the United States for decades following Van Emperger's return to Europe in 1896, and its American popularity contributed greatly to its worldwide dissemination. What Van Emperger valued about reinforced concrete, however, were sculptural qualities coupled with the potential for monumentality that were more appreciated by established German architects in the last years before World War I than by their avant-garde post-war successors. Advocating for, and I quote, a new architecture without any imitation of the wooden or iron past, he particularly admired buildings such as those that rose in Breslau, now Wrocław in Poland, just before the war. A particular favorite was the Market Hall with its innovative parabolic arches. The city's wave of experimentation with the material, which also included notable contributions by Hans Polzig, would culminate in Max Berg's Centennial Hall, one of the engineering marvels of the day, and much more daring in many respects in its construction than the Bauhaus was more than a dozen years later. Although the Dessau Bauhaus building was innovative from a stylistic point of view, reinforced concrete had already been assimilated into a wide variety of aesthetically ambitious German buildings both before and after World War I. That the German construction industry was well aware of a much wider range of American uses of the material than the Fordist paradigm which the Bauhaus and contemporary structures such as Mendelssohn's Chemnitz and Stuttgart Schachenstores so obviously, quote, undoubtedly made it easier for these architects to build their visions of the new. Finally, to fully understand even iconic buildings like the Bauhaus, we need to look more carefully at the built environment in which they were embedded. One, for instance, that has room for factories like the Daimler one I already showed you, and the Steiff factory commissioned by Margareta Steiff for her teddy bear business. Teddy bears, after all, were just as modern as automobiles, although that's admittedly a story for another day. Thank you.